All right, we'll be getting started in just a second. We have one more person from the waiting room who is connecting the audio, so um, should be pretty soon. All right. Um, so everyone, there we go. All right, so everyone, welcome to a symposium, I guess you could say. This will be on applications in an AI and tech world. And as you can see, it is going to be hosted by Kevin Chu. Um, so basically, I'll kind of give you a rundown of what's going to happen here. This session should take around an hour, so we'll be done by the next hour and like 30 minutes, so depending what time that is. But either way, that should be how long it takes. Oops, I'm gonna go through our agenda for today. So first of all is the introduction, which I'll get into a second, and then next will be Kevin's presentation, and then we'll have a Q&A session. So to begin, my name is Anderson. I will be the host for this session. But most importantly, we have Kevin, who, as I remember, was very successful in the what is it called, the USACO, which is the United States. I believe it's a computing competition. And so that kind of gives you an idea why he's here to talk about AI and machine learning. And he'll kind of talk more about that. So I guess you can kind of go ahead and introduce yourself, Kevin.
Yeah, hello everyone. My name is Kevin. I'm currently a rising 12th grader in Irvine, California, and I'm interested in AI and machine learning, making like neural network stuff and making AI like recognize images, play games, and like stuff like that.
Yeah. So Kevin here will be presenting. And then he'll be presenting on machine learning and AI, like you just mentioned. But if you do happen to have a question, which is very possible, please be sure to leave it to the end for our dedicated Q&A session. Just so we don't interrupt the flow of the presentation, and ensure we have enough time to go through everything. But other than that, we're gonna go ahead and get started. So Kevin, I will allow you to share now. You should be able to.
Okay, thanks. Can you see my screen?
Yep, we can.
Okay, cool. Just put it in presentation mode.
Yeah, there we go.
Yeah. So as I said, today I'll be talking about AI and tech. And first I'll go through about what generally is machine learning and how does it work, what's its intuition. And then I'll talk about some of the applications that it can be used for. And then I'll share some popular AI examples and then my own little AI projects. So yeah, let's begin. So you might ask, what is AI and machine learning in general? And AI is based on a abundance of data on the internet. With so many users using the internet these days, we have lots of data, and we can take this data and organize it into input and output, such as like millions and billions of questions and answers. And we can make the AI do those questions on itself, given the correct answers. And that's called training. So using like the million and billion examples of data, we can let the machine learning be able to do the questions themselves and then try to find the connections of the questions to the answers without any like other humans trying to tell it what exactly to do or like what are the strategies. We just give the AI the method to learn, and then from there it will be able to find its own like patterns and connections between the input and the output. So yeah, AI is basically anything that can perform tasks and make decisions without any specific human instructions. So some of the examples of AI that you can see are in this image. First of all, being natural language processing. That is able to understand like human language. So it's able to speak English, translate between different languages, such as English, Spanish, and Chinese. And then even being able to understand like the sentiment of people's conversations, being able to distinguish between like good reviews on the internet and bad reviews. So yeah, that's natural language processing. Also, it's used in robotics, such as like vacuum machines in the house that can like automatic. I don't know if you guys seen those things, like the things that can automatically clean your house. So yeah, that also uses machine learning to like learn the space in your house. There's autonomous vehicles, which is a big one. It's able to do like full self-driving, being able to control the speed on its own, stay in the lane, self-steering, being able to figure out its own path, and then like detect objects that are on the street so you don't collide with it. And that also uses the last one here, which is computer vision. And computer vision is basically the idea of being able to recognize images and being able to identify different things in different images, such as object detection. And yeah. Here are some more applications. One of the applications I'm interested in is healthcare, where AI is able to do medical diagnosis on itself, like being able to diagnose diseases such as like lung disease or heart cancer, such as things such as that you can look at like image data and then being able to form its own decisions about if a patient has like disease or is healthy or not. And then yeah, automobiles, so self-driving cars, finance, surveillance, social media. Social media, like people can use AI to build recommender systems to show like posts that you likely might be interested in based on your previous posts, your previous usage, and your previous viewing history. We have entertainment, so similar idea, like on YouTube, they use an AI algorithm to recommend certain videos to you that you might be interested in. And then education, AI can help you like write essays, do math equations, yeah, space exploration, gaming, robotics, agriculture, and e-commerce. On the right here, we can see a little bit more like specific examples. So yeah, personalized user experience, like I said, like those recommender systems that create a personalized user experience for you that recommends certain like videos or posts or social media posts that you are interested in. Online advertising, similar idea. Web design, voice search optimization, like Siri that you can use on your iPhone. It's part of natural language processing as well, that's able to understand a human's voice and then being able to to map your voice to the text that you're saying. E-commerce, email, content creation, content generation. Content generation is a big one I'm really interested in. Basically, you can generate like your own stories, essays, even your own images, such as with ChatGPT or DALL-E, if you've heard of that. So basically, you're able to give it some like examples of past images and then let it like train on that. And then after that, you can give it an idea of what you want to generate through text. Like you tell it what to generate, and then it's able to generate lots of images that are like according to your text. Predictive analysis, AI chatbots, which are really big, for example, ChatGPT. And yeah, so these are some big applications in AI. Basically, AI can do pretty much all the everyday things that you can think of. And yeah, anything that a human can basically do, AI can like do some massive training on that, and then being able to learn the connections and then being able to do it itself. So yeah. Next up, I would like to talk about which language you can use for machine learning in case you're interested in this and you want to try it out yourself. Being able to use a programming language and program your own machine learning is pretty important. So there are two languages for machine learning, one being Python and the other being R. Python is great because Python is really simple to use. It's really easy to learn and easy to read, and it has a lot of different use cases. It's very versatile. It's really great for machine learning because of all the support it has. There's a great community of people who use Python for machine learning, and there's lots of libraries that have been built to help accomplish these machine learning tasks. So some of these are in the image you can see here, with TensorFlow and PyTorch being able to build like really complex advanced neural network models. Keras also for neural networks. We have Matplotlib, and Matplotlib is for graphing data to visualize your data sets. NumPy is for doing like complex math calculations with like matrices and stuff. Same with SciPy. Scikit-learn is for like doing traditional machine learning techniques such as like linear regression, stuff like that. Pandas is great for manipulating data sets and data frames, being able to clean your data with it. And Theano is also like NumPy for math. And then the other language is R. And R is really great for just general data science, being able to handle a massive amount of data, being able to clean that data, manipulate that data to make it into a usable form, and then also visualizing that data. So yeah, it's really great for working with data and then being able to like do some statistical analysis on that and then form your own conclusions. And I would recommend Python because Python is really easy to learn at first, and Python has a lot of use cases. Like I said, it's very versatile. So you can, even if you don't do machine learning, you could create like simple scripts, or you can even create simple games or help it. You can make it like, you can use it to make simple games, make like backend web frameworks. So yeah, there's a lot of use cases for Python. So if you're interested in programming, I would highly recommend Python as your first language. But yeah, the next projects that I will show are all created with Python. So yeah, Python is probably the most popular language for machine learning right now. Oh yeah, and before I show some of my own projects, I'll talk about ChatGPT. ChatGPT is really popular, and in case you haven't tried it or heard of it yourself, I'll quickly show a demo, and I'll try to explain like briefly how it generally works. And actually, I'll just like put one of these questions into there just to show you like how cool it is. So we can give it any sort of question. Hold on, sorry, it's not working. Let me reload. Yeah, so we can give it any question, and it's able to find the connections between the question and the answers based on its like massive training with text data. So yeah, I just asked it what's ChatGPT used for, and it just gave me some of these use cases, common use cases. So natural language understanding, so being able to like understand English, being able to speak English, generate its own essays and responses. Content generation, language translation. Yeah, so yeah, it's also really cool because it can understand multiple different languages, and there's customer support, personal assistance, education and learning, creative writing, game development, research and exploration, entertainment. Yeah, also game development is pretty cool because ChatGPT can not only generate like text responses, but you can also generate code with it. So let's say like I wanted to make a game of tic-tac-toe in Python. And it's able to generate all the code. And most of the time it actually works unless it's like a super difficult, complex case. But yeah, this should work, and it's really cool that it's able to actually understand the code and being able to write it itself. I'll talk about generally like how it works. So basically ChatGPT is based on like a massive neural network that's called a transformer. And this transformer is really cool because it can understand the connections between like different words in a sentence, such as before and after logic or cause and effect. So like, as we can see in these like responses, the responses after like the sentence is all based on the ideas from before. So nothing is like completely random. It keeps the overall main idea constant. It keeps the main idea the same, and it generates like more information that builds on top of the previous ideas. And that is done with a large neural network, large language model that can that is trained on like billions and more than billions of like text data, articles, and websites, and it's able to form like billions of connections between different words, so that when you give it some words or some inputs, it can find like the most connected words or ideas and then generate that as output to you. So yeah, what is it trained on? It's trained on like articles and websites, anything on the internet, any public material that is, I think, I believe from like from 2021 to now. So 2 years of like all the data online. What's the underlying architecture of ChatGPT? Yeah, so it's based on a transformer model that is able to understand the ideas of previous conversations and try to connect that to your current conversations. And it does that not only in like a context of a sentence, it also does that in like paragraphs and like even multiple different conversations. It's able to connect those ideas. Yeah, so does ChatGPT understand the context of previous conversations? And yeah, because of the transformer architecture model that it uses. Yeah, cool. And then next, that's ChatGPT. I'll talk about some of my projects next. And yeah, like I said, my projects are all created like with Python. They might not be as like complex or complicated as ChatGPT, but here are just like some of the simple examples of projects that you can create like pretty quickly. So the first one I would like to talk about is using AI to play games. And I'll show that with my AI that is able to play Snake using a method called reinforcement learning. So in case you don't know what Snake is, it's basically a game where you're the snake, and in the beginning you have probably like 3 blocks in length. And then the goal of the game is basically to control the snake and go around the board to eat these apples and to grow your own snake so that it gets longer. And as it gets longer, your score gets higher. And yeah, basically you just want to keep eating these apples without bumping into yourself or bumping into the walls, which will cause you to die. So yeah, next I'll talk about generally how my Snake AI like kind of works. And later I'll show a demo, but first I'll just give a brief overview about like how it generally works. So yeah, what does the Snake actually know? So what inputs am I feeding into this Snake AI? And the first thing that the Snake needs to know is the location of the food. So is it like on top of it? How far is it away from it? Is it to the left of it, to the right of it, or below it? So the snake actually knows where the food is and then can be trained to actually like go in the direction of the food. Next, we know the position of the snake's head. The snake knows like where it is in the context of the board. Next, we have it can sense the danger to the 4 directions of it. So it knows if it's going to collide with itself or the wall to the left of it, to the right of it, above it or below it. And it can do that up to 5 blocks away. So not just like the block right next to it, but 1, 2, 3, 4, 5 blocks away, it can all sense if it will collide with itself within those 5 blocks or with the wall. And then lastly, we have its own current move direction. So the snake knows that if it's right now going up, if it's going up, left, right, or down. So yeah, with all of these things that the snake is able to know, we can train the snake to be able to make decisions on whether it should go left, up, right, or down. So yeah, and that's fed through a thing called a artificial neural network. And basically, this idea is based on like the human brain and how the human brain has a ton of neurons and different connections between these neurons. So with different inputs, different input neurons being fired, then you trigger different other neurons in the brain, and then eventually that will cause an output or an action to happen. And same thing here with the artificial neural network. But here, as the input, I will give everything that the snake knows that I talked about from the previous slide. So like the current move direction or the danger or where the food is, I'll give that all into the neural network. And then the neural network somehow is able to process all that input, make the connections, and then being able to make a best prediction of which action to take. So for example, if the food is above it, then the best action probably to take is to go up to maximize your score. And the way that this artificial neural network kind of works is that given the inputs, these neurons here in the middle, they can kind of find like the features or the patterns in each game state, and then connect that to the best action that is possible for the snake. So so like I said, if the food is like above it, maybe like a neuron in the middle can recognize that the food is above it. So I will go up to get a better score. So then it finally will output to go up. Or another example would be like, or if I see I'm gonna collide into the wall like 3 blocks away from myself, and it triggers another neuron in the middle, then it can tell the final neuron that it should probably turn right to try to avoid the wall on the left. So this is kind of a basic model of a neural network. The real neural network kind of like looks like this. It's a lot more complicated. There's lots of input neurons and then much more like hidden layers you can see here that can better help find more like complex patterns or connections between the inputs and the outputs. And the input neurons are like fully connected to these hidden layers, meaning there could be like millions of connections between these neurons that is able to allow each of the neurons to communicate to other neurons, so it can find like really complex patterns between the inputs and the outputs. So now we know kind of like what a neural network is and how the snake actually like makes its predictions. How is it like actually trained? So how is like the neural network actually trained to become better? And here, in this case, we do that with a technique called reinforcement learning. And reinforcement learning basically is this agent here, which is the snake, takes a action in the game board. So like whether it moves up, left, or right. And then given the action that it takes, it returns a new game state about the state of the game, whether the snake grew longer or died. And based on that game state or the result, we give it a reward. And the snake agent gains a reward when it prolongs its life, so it doesn't die, or it goes to eat the food. And we also give it a punishment if it collides with itself or the wall, or does not go for the food. So based on the reward, the agent knows like which action is best to take in this environment. So if I go eat an apple, then I'm getting a reward, and then the agent knows that, oh, that's a really good move. So I should probably take that action again next time. So then that will help update the neural network to know that in that specific game state, probably going up to go eat the apple is the best move. So from then it will always like make that move. Or in another case, if it's given a punishment, a negative reward, such as like if it collides with the wall, then the agent knows that that's probably not a great move. So then it will try to stop doing that the next time, and the neural network is updated so that if you see that case, then the neural network does not make the prediction to like collide with the wall anymore and chooses a better move next time. So yeah, given the feedback from the rewards, the neural network is improved as it plays the game itself for every set of action it takes. So yeah, now we kind of like know generally how it works. I'll show a demo of the actual Snake AI, so we can like better understand it. Let me share my other screen. Okay, yeah, here's the code. I'll show a training process of the snake. So at first, the neural network is like completely random. So it doesn't like know what to do. It's just making random moves that's exploring the board. And yeah, just randomly turning up, down, left, right. And it's not really going for the food and it doesn't know if it's going to die. But as it starts to kind of eat the food, then it's given a reward that says, oh, you've done something right. So next time you should probably do it again. And yeah, I'll speed up the training process a little bit so it can get better as it plays the game itself.
Sorry, Kevin, we don't see the snake on your screen.
Oh,
I'm sorry. Wait, what?
hold on. I think I didn't share the right screen.
Oh, that's probably why.
Does this work? Wait, that's not the right screen. Yeah, this should be good. Okay, yeah. So like I said, as you can see here, the snake is kind of like, wait, can we see it now?
Yes.
Okay. So yeah, I was saying the snake kind of like is generally making like random moves going left, right, up and down. It doesn't really know what to do until it starts to kind of eat the food, and it starts improving. So if it starts to eat the food, it's given a reward, and that will tell it that you've done something good, and the neural network is updated to do that action again. So it learns to go for the food again in those kinds of game states. I'll speed it up a little bit. So yeah, just playing the game itself over and over again until it gets better. So that's sort of going for the food now, as you can see. It knows where the food location is, and then it's able to connect that to the snake's actions. So it's probably still dying right now because it doesn't know how to like avoid collisions, but it should get better soon. So the high score is already 37, and yeah, it's pretty quick how the snake can learn using this technique. So I'll just let her train for a while and see how much better it can get. So yeah, it kind of knows how to go with the food and then not to collide with the wall. Sometimes it's still finding it hard to make the connection of like bumping with itself. Because it's kind of hard to know you should probably turn left if there's like if you see yourself bumping with yourself like 5 blocks away. So yeah, probably with the longer training time it's able to get better. But yeah, I think at this point it's probably already better than me at playing the game. Yeah, I'll just let this run for probably like 2 more minutes. So yeah, for each of the move that it's taking, the neural network is like updating itself to better connect the input game states of what the snake knows to the best action that it can take. And also the reinforcement learning technique not only considers like what's the immediate best action it can take, but also considers the next few game states I can reach. So if I turn left, what's the next state? And if I turn left, then the best move would be probably to like turn right. So it considers the next few moves in advance as well. So yeah, I also, oh yeah, there we go. It's 81 now. So yeah, it's basically all trained based on the reinforcement learning technique where it just plays the game over itself. And then I tell it like what's the reward and punishment it gets, and then it's able to like learn to maximize the reward and try to get a higher score and not die. So yeah, I'll stop it there. There's still other stuff to talk about, so I'll stop it there. So yeah. So after like, I don't know, 140 games, it's able to get a high score of like 81, which is probably not bad. Okay. Okay. Yeah, next, I want to talk about like computer vision examples where we can classify or recognize different numbers and different images. So first, we can also use artificial neural networks to help us recognize different images of numbers. And as you can see here, here are some like example images of what the neural network is trained on. These are just like 28 by 28 pixels of like grayscale images of numbers. And here we have like around 50,000 example images. And those images with the corresponding like correct answers. So for example, here's a image of 5, and we actually say it's like the correct answer is a 5. And we pass these like images and the answers, or like the labels that they call it, into this network to train. And basically the input neurons are like each of the pixels in the 28 by 28 image. So we passed in each of these pixels into the network, and then these neurons in the middle are able to figure out the connections of the different pixels, the values of the different pixels to the correct number. And yeah, so if we let it train on like 50,000, then it's able to learn like what a 5 should look like, what a 0 should look like, what a 1 should look like. And yeah, here's like what kind of the example data set looks like. So we give it some different like ways of like writing 0. They all look a little bit different. So it's not just based on like the same shape of 0. So even if we give it something that's a little bit different, it still can recognize the similar shape. So yeah, so we can write like different 1s, different 2s. They all look like slightly different. So we can get better results with our neural network, and being able to find the general pattern and not just looking at like the specific pixels. Here are some example predictions with my neural network. So yeah, here's a 9, and yeah, I got it. It's a 0, I got it. Here's a 2, I got it, and yeah. Here's some more examples. Here's a 1 here. Yeah, I got it. Prediction's a 1. 8, it predicts as an 8. But here, it should have been, yeah, there should have been a 5, but my neural network predicted a 3, which is not correct. And it's kind of understandable that like maybe this 5 looks a little bit like a 3. It's kind of confusing. So yeah, the neural network is like not perfect. It doesn't have like 100% accuracy, and none of the AIs have that. Like it's really difficult for an AI to have 100% accuracy, but a 96% accuracy is still pretty good, and that's honestly pretty close to how a human would do. Yeah, and then I would like to talk about a different example of image recognition AI that later in my project, I'll show like being able to recognize between cats and dog images. And this is done with a technique called convolutional neural networks, which is a little bit different than artificial neural networks in that it looks for not like pixel by pixel, but looks for like general certain features in the images. So here the image, you can kind of see it learned kind of like these like feature maps or like kind of filters that it applies onto the image to look at like the general shape of the images instead of like the artificial network like passing pixel by pixel in there. So this convolutional neural network, as you can see, for this car, it kind of learned like the shape of a car, and the other like kind of filter feature maps that learn is just like random noise, maybe for like backgrounds or something like that. So we can distinguish like different objects. So maybe for maybe instead of a car here, it also has like a feature map for like maybe a truck or a motorcycle, and it's able to kind of find the similarity between these feature maps and the actual images, and then make the best guess of what the actual object is. So here we can see this car, and this car has like a 95% like similarity, and then we can pretty confidently say that this is a car. Now, in real convolutional neural networks, it probably won't look for like this big of a feature, where it kind of like sees the entire shape of the car. Maybe it will look for like a wheel, look for like a headlight or a window, or like the general outline of the car a little bit instead of the overall like complete shape. And then using like those different features, like small features, it's able to add them up and then make the best prediction of what the actual object is based on all of those features. So yeah, how we train convolutional neural networks is the same way as how we train other AI and regular neural networks. And that's basically by looking at thousands or millions of example images. And sorry. Yeah, so I've fed the neural network like thousands of different dogs and cats images. They're not really selected, they're just random. They could have like different backgrounds or noises in them. But yeah, I give them the images and I give it like the correct answer. Like if this one's a dog, I tell it, the neural network, it's actually a dog. If it's a cat, I tell it it's actually a cat. And I feed them into the neural network. And then at first, the neural network is like completely random, just makes a random guess of it, if it's a dog or a cat. But then I'll tell it the correct answer, and then it's able to learn based on its mistakes and errors, and then update these connections between the neurons or the feature maps so that it can make better guesses next time. Yeah, here are some of my recognition results for my dogs versus cat example. And yeah, here it successfully identifies as a dog. This is successfully identifies a cat. But for this one, it thought it was a dog. I guess it's a little bit like it's a little bit harder for the neural network to recognize this one, maybe because of like its color or something. I'm not sure. But yeah, it's not perfect. It has a overall of like 90% accuracy at recognizing different dogs and cats images, which is not bad. Maybe like a little worse than a human, but it's not too bad. And this one, it's lower than the number one because this one is much more complicated. The shapes of dogs and cats are like much more complicated. They look like pretty much a little bit similar at first until you look at like the specific features. And yeah, they're also in color, which makes the neural network like much bigger and much harder to like find all the patterns between dogs, differences between dogs and cats. And yeah, let's see how much time we have. Oh, Anderson, do we have only like 15 minutes left?
Yeah, but how long do you have to, like, how long is your presentation gonna be, do you think?
Oh, because I also prepared a Kahoot game for everyone to play.
Ooh,
Yeah, because
yeah,
I'd rather have we do that than go to the next section. I think we'll run out of time if we do this.
I guess we could get an idea from the audience if they'd like to play the Kahoot because,
Yeah.
yeah, I guess if you type in chat if you'd like to, because that makes things a little bit easier. But otherwise we might not be able to go through the Kahoot game depending on, how the
Oh
audience
yeah,
is doing.
because there's also a Q&A session, right?
Yeah, that's true. We do want to save around maybe like 5 to 10 minutes for our what's called the Q&A session. So I guess for now, I guess it'd be better. I mean, I would like the audience to decide, but we can always have another session for you, Kevin. So
Oh, okay,
yeah, we can go ahead and continue on with your slide deck then.
sure.
Yeah, thank you.
So this project is not completely based on AI. It's kind of like about like data processing before AI, because in the real world the data can be like really messy and it could be like not really usable to help train the AI, especially to get into like the input and output format. So I'll talk a little bit about that. So first, we can talk about how to use Python to do data processing, and that's done with the module called Pandas that I mentioned earlier. And Pandas is really good at cleaning and organizing the raw data for building and training machine learning models. And Panda has this like feature called data frames that makes it easy to clean the data, maybe like reduce the data a little bit, transform the data, create new columns, new rows, and yeah, stuff like that. So my project with like data manipulation is the Stockbot here, and the Stockbot can manipulate data to gather stock data from specific time frames, and it can process pre-market and after hours, which most other like bots don't do. And it can also find like gap stats between the pre-market data and the actual opening. For any like, it can calculate like the different gap percentages for each stock, and then calculate the different gap stats to show. And then it can also calculate stats such as the average high of day percentage, average high of day time, and like much more things that can provide like more information of the stocks. So yeah, here's kind of like what my stocks bot can do. Here's all the functions that it can perform. It can generate a chart of the stock data. And this image doesn't really show it, but it can also generate like find the data between like when the stock is like not open or after it's closed. And here is me using the function of gap stats, so we can find the data between the time that the stock market is not open, and it can find like the change in the prices. You can find the average high of day times. I'm not really familiar with this stock data, but yeah, I can just calculate all of these things that can be used to better analyze these stocks. And yeah, so like these things can help, like if you can calculate better input data for like machine learning, you can use it to like train it better and then find like better connections. Oh yeah, and in case you don't use Python for machine learning, here's this stock bot here. It's a bot in Discord. It's also created with Python just to show like the versatility of Python and everything it can do. So it can like obviously graph data, it can create different functions, and yeah, generally just you can make a lot of bots with it. And here is another example of all the data that the stock bot can retrieve using like the Python Pandas module. So we have like all this data, and it's able to calculate like the high of like 1 minute, high of 5 minutes, and things. Just basically able to generate like new columns based on the raw data that it receives before about the opening prices, high prices, low prices, and close prices, and stuff like that. And here you can see you can do it also for like process the data, so then you only show like the data for that date. So here's all the data for June 13th, and then here's all the data for June 16th. Oh yeah, that's it. If you guys have any questions about anything, I can answer them now. Let's see the chat.
Yeah, so I just want to ask, you said that the stock bot was actually created using Python, but then what they do, like incorporate it into the Discord API or something?
Yeah, so basically I use the Python library called PyCord that's able to yeah, make it really easy to create a Python bot. It's basically a library that has all of the defined functions for you. And all you just have to do is just, I do my data processing and then be able to like display it on the, transfer all the data into Discord with that API. Yeah.
Okay. So since Python's able to be like basically brought over into other like I guess other platforms, do you think that there's a possibility that in the future we'll have like companies pulling through like Python, and then incorporating it into their own systems to help them, I don't know, I guess in the case of like a investment firm, help them make better investments? Think that's possible?
Yeah. Python's already like used widely right now. People in companies all use Python for machine learning, and then those machine learning can help make like decisions for the company, stuff like that. So yeah, definitely.
So wait, okay. First of all, since they make decisions for the company, but then we see examples where they have maybe like a 90% success rate, wouldn't that kind of be like, wouldn't that cause like problems if they didn't succeed or if they've made a wrong miscalculation?
Oh, they probably don't make like the final decision, the absolute decision. It just gives like a better example since it can be since it can look at like so much data, so much more data than humans. It's able probably to form a better judgment based on like looking at a bigger picture. But yeah, humans also have an impact on it. It can judge like what's the best decision.
So make a couple like proposals for higher ups to think of or think
Yeah,
on.
yeah,
Okay,
definitely.
interesting. Does anyone else have any other questions for Kevin?
I have a question.
Yeah.
How long on average does it take you to write a program?
Well, it depends. Like at first, sometimes if you write a program and you encounter a lot of errors, maybe it takes like a few days to fix. But for something like my Snake AI, I would say I probably finished that in like around 3 days, working about like I don't know 5 hours for each day. And I didn't like invent everything on my own. I've used like past research examples and like use kind of their ideas to build on top of it and try to like build on top of that. But yeah, so I would say if you're trying to write a program like the Snake AI or the Stockbot, it probably takes maybe like 3 days to like a week or something like that.
Seems that Audrey has a question.
Yeah, I just wanted to ask that, like as we've seen today, like there's evidence that like AI can like genuinely learn like humans. So do you think AI could take over the world?
Yeah, that's a tough question.
Valid question right there.
For I think at like right now, it's still far from that. Probably like
How
the
about
most
in the eminent future?
I could definitely see it happening if it like if something called AGI, artificial general intelligence, comes out. It's able to have its like own intuition and able to learn like anything it wants. But for right now, with all of like the supervised learning techniques we have right now that we tell it what to learn, it's not gonna happen. But like it could happen in the future if there are more inventions.
Okay.
All right. Does anyone else have any other questions?
I kind of have another one. So for like maybe our generation specifically, do you think our jobs would be like taken by AI or people like using AI?
It's true. A lot of people are worried about that.
I would think some of like the repetitive tasks and like can definitely be taken over by AI. There will probably be a point that AI can have a better accuracy than humans. For example, in like healthcare, they probably make better decisions than doctors do at some point. But I think humans have like humans can do tasks that are more creative, and we can do tasks that generally require more creativity, and AI will be able to help us do some of the more repetitive tasks while we can do like invent more things.
So, you brought up how eventually AI could make better decisions than medical professionals. And I'm actually somebody who's looking into going to medical field.
Mhm.
And one of the main reasons I chose to do this was actually because it doesn't seem like that the AI will be able to replace medical professionals as much because of like the personal, like, human interaction
Yeah, yeah.
aspect of it. So do you think in the case in like the future that people would be willing to accept medical advice from someone like, I don't know, a human doctor, sorry, more compared to an AI or more compared to like a human doctor? Because while a doctor may have less technical knowledge than the AI, there is also the fact that they are a human as well.
Yeah, I think in some point in the future, the AI could probably learn kind of to resemble like the human, a little bit of the human emotions. But yeah, it would definitely take a long transitions for humans to trust that. It's definitely hard for AI to do that, and it's a hard question to know if AI can do that as good as humans. But yeah, that's a tough question.
Hopefully my job doesn't get replaced and then all right. Real quick, does anyone have any wait, sorry, Kevin?
Yeah. What's the first language you learned?
Oh yeah, Python definitely, because there's lots of versatility. You can create lots of things, and it's probably one of the most simplest language you can learn at first. You can pick it up really fast. It's really easy to read. It pretty much reads like English, honestly.
When did you start learning Python? Like, how long have you been doing that kind of stuff?
I'd say around, I'm a 12th grade now. Around 9th grade, probably like 3-4 years ago.
Hmm. Hmm.
Yeah.
Was it in like a high school sponsored class or something?
No, I didn't really take any classes for it. It's pretty much just during COVID. It's like staying at home all the time. So I learned it pretty much just through YouTube. There's a lot of great tutorials, and you can just follow through that and then be able to pick up really fast.
Okay. Does anyone else have any other questions? We are pretty much on track to end, so if no one else has any other questions. All right. If that's the case, then well, first of all, thank you all for coming. I hope you guys learned something. Because as we all know, AI has been taking leaps and bounds. With the introduction of ChatGPT, like, I don't know, Midjourney, stuff like that, and like character AI. A lot of progress has been made. And I also want to make it clear that we will probably have another session on this. I think it's likely that we will. So if you guys enjoyed this, or at least learned something from this, consider coming to the next one. But other than that, actually, I forgot. We'll probably be including the interactive Kahoot in the next one, Kevin.
Next time,
so
yeah.
don't get
We'll
rid of
probably
that
do
yet.
probably do in the beginning next
but
time.
yeah.
Even.
So yeah, that'll be kind of it for today. Again, if you learned something, please do consider going to the next one. And other than that, also thank you so much, Kevin, for giving us this presentation and also taking us into heart and creating a whole Kahoot that we unfortunately didn't get to use today. But overall, I mean, great presentation. I learned a lot.
Thanks.
So, I mean, that'll do it, guys. Thanks for being here.
Yeah, thank you everyone for coming.
Yeah.
Thank you.
Yeah. Bye.
Thank you. Bye bye.
Have a good
Thank
weekend.
you. Bye.
Bye-bye.